Hello and welcome to the Singularity Lab. We've got an amazing show for you tonight. You're joining us, your home for breaking science, technology, and futurism. Kristen, how the heck are you?
Good. Did we start out loud? Somebody said we got loud.
Are we yelling? Wake up. Yeah, we've got an amazing show for you guys today. We've got Dr. Kevin Knuth. He's going to be joining us to talk about his unique theory of everything called influence theory, as well as the physics of TicTac UFOs, UAPs, which he's been studying. In the second hour, we're going to be talking to Zac Cichy, Aaron Desario, and Jazz Shaw to discuss Zac's theory on the technological singularity. It's going to be an awesome show. Welcome, everybody. Welcome, Justin. Yes, rather, B-Squidding is off today. Zero Cool, Night Gazer. What's up, Michael? UFO Blueprint, good to see you. Case for Infinity, amazing to have you all here today. As you know, we generally start the show getting back to first principles. I think it's important to ensure that we are avoiding cognitive dissonance by avoiding logical fallacies and cognitive bias. So I'm going to pull our little cards here, and we'll see what we got today. So our cognitive bias of the day is you unfairly favor those who belong to your group. For example, we presume that we're fair and impartial, but the truth is that we automatically favor those who are most like us or belong to our groups. Try to imagine ourselves in the position of those in out groups, whilst also attempting to be dispassionate when judging those who belong to groups. You find yourself doing that ever, Kristen?
Well, of course. I mean, it would be impossible not to. But it's all the more reason to actively attempt to be at least an outside member of more groups, to have a basic understanding of different sorts of groups,
Right.
Like both of my sets of grandparents were farmers. So I have some
connection,
loyalty to that perception of how things are. You know what I mean?
Right. And I think politics as well. People, if you're blue or if you're red, you can hear, this is something fascinating that, when you talk about cognitive bias and bias theory, people who are in a particular group, depending on whether the person is red or blue, they'll agree or disagree, having not seen the person who said it, and then they'll change their mind if it's somebody from the opposing group. So that's a cognitive bias that I think we all spend a lot of time in. I think it's kind of dangerous, don't you?
Well, yeah, but then when you have no group, what does that make you?
An outsider. So you defend the outsiders, the rebels, which I get that too. All right. So without further ado, we've got an amazing guest for you, and I'm so excited to have him here. Dr. Kevin Knuth is a professor of physics at the University of Albany, a former NASA scientist, and the editor-in-chief of the Entropy journal. He has a unique theory of everything called influence theory. Kevin is a contributor to the Scientific Coalition for UAP Studies. Ladies and gentlemen, welcome the one, the only Kevin Knuth. Kevin, how are you?
Very good. Thank you for your kind introduction, and thank you for having me.
Well, I tell you what, we have had, I can't tell you how many people have said, my God, Michael, the fact that you haven't had Kevin Knuth on this show, it's like you're not even interested in physics or UAPs. You haven't had Kevin. So it's a pleasure to have you.
Thank you.
Yeah, absolutely. So let's get right into it. For folks who don't know, a theory of everything is a hypothetical, singular, all-encompassing, coherent theoretical framework of physics that fully explains and links together all physical aspects of the universe. Most commonly, it's known for trying to combine the different aspects of Newtonian physics and quantum mechanics. Kevin, can you kind of give us an idea of what sent you on this journey, hunting for this theory of everything?
Right. I think I I don't really look at it as a theory of everything. I hope that it's a theory of some things at least. And I think that's more of the way I think about it. And the idea is that I want to understand the foundations of physics. I ask the question, why are the laws of physics the way they are? Why don't we have other laws? And you can approach this from, people have approached this from different ways. One is, the laws of physics were dictated by Mother Nature, and we all have to follow them. And so why is that? And if that's the case, and is that really what we believe? And what does it mean for there to be a law of physics? And what does that really entail? And there are no good answers to this at this point. In fact, it's hypothesized that if there are other universes, if we exist in a multiverse where there are other universes, it's hypothesized that there might be universes with completely different laws of physics. So then, if you believe that may be possible, then you have to ask why. Why would one universe have one law of physics and another universe have a different set of laws of physics? And who decides that? How does that get decided? Is it a historical accident? Conditions just were right, and you lead to one set of laws, and if you get different conditions, you get a different set of laws. And if that's the case, then what are those conditions, and how does that happen? So I became interested in, I'm interested in these deeper questions. And
Yeah, it sounds a little like you're driven by some philosophy as well, yeah?
Yeah, well, it turns out to be very, very, very philosophical as well. I agree. Yeah, and that's so that's where this pretty much started. I've taken two different paths to try to answer these questions. So, and both have been productive. And one of them led to influence theory, which is what you had mentioned earlier, and another led to something related to influence theory based on some of the similar ideas. And those ideas were that they're based on the thought that so you can ask the question, why are the laws of physics mathematical? And why does that work even? How do the laws, why does math allow you to describe the universe? And that's a deep question. And so if you think about mathematics as a language where you're describing things, right? So I'm describing, if I grab some pens over here on my very messy desk, if I describe this set of pens, I can describe them with the number 5, right? That's what we typically do. We learn how to count. And we learned that if you take 2 pens and combine them with 3 pens, you get 5 pens. And it doesn't matter if you combine them this way or if you can combine them this way. That's called commutativity, which they now teach kids in school, which is good. They didn't teach this when I was in school. This is part of the new math that parents complain about. It's not hard. Sorry. if it is, we've got some serious problems with adults. So
new is hard for adults, though. It can be
hard to. Yeah, it can be. It can be. Yeah. So it doesn't matter what order I combine the pens in, and then I can actually combine them in stages. I can first combine this pen with these 2 pens, right? And then combine them with these 3 pens, and then I'll still get 5. Or I can combine this black pen with this set of 3, and I get 4 pens, and then combine it with this one, and I still get 5. So I can shuffle them, and it doesn't make any difference. I still get 5. So this was a question I actually had foolishly asked my professors in graduate school. And I was puzzled about this, not because I didn't understand why that you get 5. Of course, we all know this. You learned this very early on. What I was puzzled about was whether this is defined to be true, or if we had to somehow do experiments to discover that this was true. And it was never clear to me what the situation was. And on asking my physics professors this in graduate school, it became very clear to me that they didn't know the answers either, because the response was like, "Oh, Kevin, ask me a real question. This is obvious. If you don't know how to add at this point, we have problems." And like, that's not the issue. The issue is why it works. Why does this work? And and so Eugene Wigner, the famous physicist Eugene Wigner, has a paper called "The Unreasonable Effectiveness of Mathematics," and he expresses some of these ideas. And I was very pleased a few years later. So I got some ridicule in graduate school for having asked this question. In fact, I remember once I was in quantum field theory class, and I raised a hand, and he goes, "Yeah, I'll take the question from Kevin, who can't add over there, who doesn't know why we add things over there." And I was like, "Oh, come on, this is a valid question." And to me, it just highlighted the fact that they were not even aware of they didn't understand the level of the question, much less
have the answer.
Right.
Much less what the answer was. So, and then I came across the paper by Eugene Wigner and found that he was equally confused about some of these things. And Richard Hemming, who was an engineer, he wrote a similar paper, a paper of the same name, a kind of follow-up paper to that. He actually expressed the same kind of question, how he went around Princeton asking people, why is it when I take 6 things and combine them with 8 things, I always get 14 things? And he said he was astonished that nobody was even interested in this. So I thought, all right, I'm not alone here. I'm actually
right. You're not the only problem child in the physics department.
I'm not the only outsider here. Right. There's a few. Right. There's a small, very small group of distinguished individuals that I can identify with and have some biases toward. So so it turns out it was this question turns out to be critical to my understanding of the foundations of physics at this point. And the story kind of goes like this. I had been, at the time when I was at NASA in the early 2000s, I was interested in coming up with mathematics that describes question asking. So we have like Boolean algebra that allows you to perform operations with logical statements, right? That's what our computers do.
Right.
But we don't really have an algebra of questions. And so I can use probability theory as related to the logic of statements. We're calculating the probability that one statement implies another statement when we work with probabilities. And I wanted to come up with a measure that allowed me to consistently quantify the degree to which one question might address an issue that you want to resolve. So let's say you have a deeper issue that you're trying to resolve. Oh, it's a murder mystery. Who killed so-and-so, right? And you're a detective and you're talking to suspects. Is it better to what degree is asking a particular suspect, where they were on Tuesday night, relevant to the issue what you want to resolve? Or is it better to ask a different suspect where they were on Tuesday night? Is that going to be more informative?
Or a different question to suspect A, right?
Right. So the idea and why I was doing this at NASA is I was interested in designing artificial intelligence systems to handle experimental design in remote situations. So you put a rover on Mars and you program it to resolve an issue. Is there life on Mars? That's way too big of an issue. And then it sees some green stuff on a rock. Now, should it drill into the rock and take photographs? Is that the best question to ask? Or is it better to shoot it with a laser beam and look at Raman spectroscopy? Is that a better question to ask? And have the machine do this calculations and have the machine decide what experiments to do. And that would speed up the process, because at this point we have the machine gets up to the rock and then tells everybody back at mission control and on Earth that it's ready, and they decide what they want to do, and they program it, and they send the code up to the robot, and then the robot does its thing. And if you had a machine that could decide what experiments to do, then you could you could have much faster turnaround time and be much more efficient. And that would be better for situations when we send similar probes to Saturn's moon Titan, where you're going to have a much longer light travel turnaround time and so on. So that's what I was interested in. And I had been working with some, and now this is going to get obscure, so I'm going to have to cut this short a bit. I was looking at some derivations by Richard Cox from 1946 or so on deriving probability theory from Boolean algebra. And I was working from that starting point. And I realized something interesting, and it turns out that the symmetry of associativity, which is it doesn't matter whether I combine the red pen with these three pens first, and then, or if I combine the red pen with the black pen and then combine them together, I can group the combination in any way I want. It turns out that if you want to quantify this set of pens and this set of pens, and then you want to quantify the resulting set when you combine them, if the combining operation is associative, or if you're able to shuffle them and you get the same result, then you can mathematically prove that the only operation, the only mathematical representation you could have of these sets of objects is with numbers is addition. You would have to basically add the numbers.
Right.
And it's a little deeper than that. It's that the combination rule for the numbers when you combine the pens has to be isomorphic to addition. So it can be a transformation of addition, but it has to be an invertible transformation. You have to be able to go back and equally do addition. So you have a choice, but you can actually prove that you have to add the numbers, and that happens whenever you are able to shuffle the objects and put them together and get the same result. So
that's the process that was able to prove to you that math is real.
Yeah, well, not exactly.
Sort of.
I knew math is real, and I know math works, but
but why? Right.
But why does it work? And that was the understanding that we add things when you're able to shuffle them and combine them, and you get the same answers. Now, that doesn't always. Now, there's some interesting points to this, and that is that what I'm calling objects here is subjective, right? I'm thinking of these as pens and these as pens, right? And so that's a subjective operation. I'm doing something subjective here, yet I'm getting objective results.
Right.
Now that's strange, right? So why? And then when we talk about things in physics, we talk about an object falling and it has mass, or this object pushes on this object with a force. Those designations are all subjective. And that should make you worry a little bit if you're going to hold on to this dogmatic idea that there are laws of physics that have to be followed, because these laws of physics are being applied subjectively. So
and they're being applied subjectively. Let me make sure I understand this correctly. They're being applied subjectively because we are subjective beings looking at these objects, and it's based on, we live in a relative world, and because we live in a relative world, it's based on our perception that these are objects. Is that accurate?
Yeah. And the idea is that it highlights the fact that mathematics is simply a description, and it's a description that we choose to use. and it's designed to work. It's designed to work because we use mathematical functions that obey certain symmetries, like associativity, and it can't fail because you can shuffle all you want and you're going to get the same answer because the mathematical operation obeys the same symmetries as the objects that shore.
Unless those symmetries begin to break down in some way, which is where you have a singularity, right? Where mathematics no longer works. So the center of a black hole, mathematics no longer works. So now you have a singularity and everything breaks down. And so our math in this world is...
That's a dramatic example, and I think I mean that's fine. It's a dramatic example, but it's one we're not so familiar with, so it's harder to get your head around. So here's a simpler one. I joke. I'm not that smart. I like to keep things simple. So let's go with a simpler one. So let's say I have a box of let's see. I want to make sure I'm going to do this well. So let's say I have a box of hydrogen molecules, right? So if I have, let's say I have 3 hydrogen molecules in a box. Here's my 3 hydrogen molecules. There they are, right? And then over here, I'll have, this isn't going to work because you have to balance your equations like in chemistry, right? So then I have some oxygen molecules over in this other box, right? So these 3 hydrogen molecules give me 6 hydrogen atoms because this is H2, H2, and H2. So I've got 3 molecules in this box. I've got some oxygen over here. And so I'm going to need 3 oxygen. So I can't do that. I have to go with 6 hydrogen molecules. So let's go with 6 hydrogen molecules. That gives me 12 hydrogen atoms, right? And
need more hands.
And then I'll have 6 oxygen molecules, which will give me, or I'll get 3 oxygen molecules, which will give me 6 oxygen atoms, okay? So I have 6 hydrogens over here, and my kingdom for a piece of paper. I was just going to hold up 6 hydrogen atoms over here, or 12. How much was it? Yeah, 6 hydrogen atoms here and 3 oxygen atoms in the other box. And now, if I can combine them nicely without using associativity, without shuffling, if I get the same results, then so there's another condition called closure that comes into the proof, where you have to have the same type of stuff before you combine them as you do after. So here I was combining pens with pens, and that's why it works, right?
Right.
The problem with oxygen and hydrogen is I'm going to combine these molecules in a box, and I'm not going to have 6 hydrogen molecules and 3 oxygen molecules anymore. I'm not going to have 9 molecules in this box because they're going to recombine. I'll shake the box up so it's super hot, right? I have to shake like crazy, but I can do that. So I shake the box up so they're super hot, and these things are going to recombine, right? And they're going to recombine so that I get, thank you. That's the equation I'm trying to do in my head while I'm talking, which is hard to do math while you're talking. Right. So, So now you get, so now you combine these things, and I've got 12 atoms of hydrogen. I've got 6 atoms of oxygen floating around. These things are going to combine and make H2Os, right? And so I'm going to end up with 6 water molecules, right? So here's where addition didn't work, because we didn't have closure. We don't have the same type of stuff. The same type of stuff isn't being combined, and the result of the combination isn't the same. Shuffling. So now, so I take 6 hydrogen molecules plus 3 oxygen molecules, and I combine them. I don't have 9 molecules anymore. I have 6 molecules, but they're different, right? So that didn't work. So what we can do is we can change our description. Again, this is subjective. So I can go with the molecule description, and then we find addition doesn't work, right? However, if I go with the atomic description, I worry about the atoms. then I'm actually taking 12 hydrogen atoms and combining them with 6 oxygen atoms. And when I put them together, yeah, they make 6 water molecules, but I still have 12 hydrogen atoms and 6 oxygen atoms. I still have 18 atoms in the box.
Right.
And now addition works.
Right.
So there's a situation where addition doesn't always work. It's subjective depending on what you're talking about.
Right. So let me ask you this, because we talk about first principles here a lot, the basic building blocks of ideas. And so it seems to me that the entire idea of first principles is questionable, right? Because we're coming to it from a subjective viewpoint. There's no fundamental building block of anything. Is it because we live in this anthropocentric relative universe? Are we all just, is there any meaning to it beyond what we can create? I think Aaron Desario said it best up here when he said, is mathematics inherent to the universe, or are we projecting it into, out of chaos?
I think mathematics is our description. We invented it, and we invented it to try to quantify the universe. And why do you quantify things? You quantify them because you want to know if this is more than this, right? Is 3 more than 2?
Because we need. Sorry, go ahead.
It's also a very early building block in language. Like when two people do not speak a common language, one of the first things that you can translate to each other is 1, 2.
Right.
And that usually works, except that there is a tribe. There's a tribe in the Amazon that doesn't have the concept of numbers.
Really? You just confounded us.
Yeah.
You just confounded us.
So,
I thought we had a first. I thought Kristen just gave us a first principle, but we do not. We do not have
without numbers. And in fact, I was watching a YouTube video on this tribe, and they pointed out that somebody else. So that woman doesn't know how many children she has, and they're like, yeah, no, she doesn't know how many children she has. She doesn't even have that concept, but she knows who her children are. Right. But it really shows how innate this language has become for us. And especially now that we're technologically developed, it's essential, right? Our technology is built on this idea of being able to quantify how much more one thing is than another.
Mm-hmm.
Right. It's all subjective, right?
Doing. Yeah.
Right.
Should hit these couple questions.
Yeah, let's hit these questions real quick. Okay, Bottled Water says, yes, but if you're combining H and O without the right conditions and including electromagnetism, you will not get what you think you will. He's explaining simple chemistry and mathematics. Is that accurate?
I don't quite understand
But if you're combining H and O without the right conditions and including electromagnetism, you will not get what you think you will.
Yeah, well, that's the point. The point is
that's what you're saying, right?
You don't have closure. And is what we would say mathematically. You don't have the same, in combining set A with set B, you don't have the set of same type of objects.
Right. He also asked earlier, is that a wood-burning stove behind you?
Yeah.
It's a wood-burning stove behind me. And it's also right behind my head, that's a print of the painting of the moon by Alan Bean, the astronaut from Apollo 12.
Oh, wow.
Cool.
That's fantastic. And we had
really
one more that I wanted to get for you from Autumn Leaf. Is Kevin working with the Galileo project? And do you have any thoughts on the Galileo project?
I'm not working with the Galileo project right now. And I'm friends with several of the people working on the Galileo project. So we're in communication. Right now I'm working with UAPX. And we're working to collect our own data as well. And we've already collected some data. So we have made some progress already.
That's fantastic. Can you tell us a little bit about your interest in UAP and UFOs, kind of where that came from? I mean, a lot of, this is something that's been kind of fringe for a long time, and it's always difficult for folks in academia. I think you started talking about this stuff, before it was a little more mainstream. So it takes a lot of courage. Can you tell us a little bit about that?
I started talking about it about 2 years before the New York Times article came out in December 16th, 2017. Right. So with about the ATIP program, my interests go back to, I was fortunate to be born at the right time so that I was about 12 years old when Star Wars came out. So I was that magical age when Star Wars hit the movie theater.
Right.
And so what is it? That was like May 25th, 1977. So
Yes.
Yes, that was actually 2 days after Kristen was born, right?
Yeah, and
Yeah.
it was the
Wow.
first movie that my parents ever took me to. Obviously, probably not that early as in the run. But
Yeah.
Right. Great. Yeah. So I was at that magical age, but at that time, of course, we had television programs like In Search Of with Leonard Nimoy, and they would often cover UFO cases, and I always thought that to be interesting, and so I had some just innate interest as a teenage boy in this sort of thing, and it wasn't again till I went to graduate school. I got my master's degree at Montana State University in Bozeman, Montana. And then I got my PhD in Minnesota, University of Minnesota in Minneapolis. And it was in Minneapolis that I asked the why do we add things question. So I won't put these on the professors, the good professors in Bozeman. But I had a different question. We had another issue, and it was probably about the second week of school there. So I had just started school in the fall. I grew up in Wisconsin, so I moved out to Montana and had been there about 2 weeks. And so this would have been September of 1988. And there was a cattle mutilation on a ranch nearby Bozeman, and there were 2 cows were killed. And it was very bizarre. I'd never heard about, I grew up in Wisconsin. I knew about cow tipping. I never did that. It just sounds mean, actually.
my dad says it's impossible. They're supposed to wake up, like,
Wow.
and move.
Wow. So maybe that's about as impossible as the mutilations. I don't know. But so I'd heard of cow tipping, and I always thought that was kind of mean. But then cow mutilations is really cruel. I mean, how horrible was that? So I was, really taken aback by this whole thing, and it was bizarre. The the tongue was removed, the skin around the jaw resected, the eyeballs were missing. I think the inner ear was taken out, and this was all done, surgical precision.
Right.
And the sex organs were missing, and one of the cows had a cylindrical hole punched through it, just like a core. Who takes a core sample of a cow, and what good is that? It doesn't. It's just bizarre. So So the next day, after this is all over the news and everybody's freaking out about Satanists and
Right.
aliens, right? And these are the 2 crazy. So people had seen UFOs that night too. So the UFOs were also reported to the sheriff's office. So this was all over the news. So several of us graduate students are discussing this in the hallway, and it was really mostly the new graduate students who had moved to Montana. So I think we were really mostly coming to terms with what kind of messed up place have we all just moved to, and we're going to have to live here for the next 4 or 5 years. And how do we deal with this?
Right.
And so we had this heated discussion in the hallway, and I remember saying something like, I don't know how Satanists would do it, and I don't know why aliens would. So I don't understand any of this. And then one of the professors came out of his office from down the hallway and came down to see what the commotion was about. And I'm sure we were bothering him. I mean, this was a very dynamic conversation. And he came down to find out what was going on, and we told him, and he said, well, yeah, things are very strange. And yeah, cattle mutilations do sometimes happen around here. That's true. And they never figure out who did it. And so it's always very strange. And sometimes there are UFOs seen around the same time, and that's weird too. And then he said, but you know what's really strange? He said, I have some friends who work up at Malmstrom Air Force Base at the nuclear missile sites, the ICBM missile sites, and they have problems up there with UFOs flying over the ICBM missiles and shutting them down. And he's one of our professors and we're new graduate students. So you listen politely.
Right.
If we walked away, I'll be honest, we laughed our asses off. Our aliens are shutting down nuclear missiles. Are you kidding me? And that became kind of the running gag through the whole school year, because anytime somebody would say something crazy, somebody would retort with, well, what's really weird is the aliens are shutting down our nuclear missiles. So I always remembered this, and keep in mind, this is September of 1988, when this wasn't really publicly known yet. So now fast forward 30 years, and around 2018 or so, right? So I'm a professor at University of Albany at this time, and I'm teaching an astrophysics class, and we have a few lectures on astrobiology coming up. And the students were interested in the possibility of intelligent life elsewhere, and so we are going to spend some time talking about this and the Drake equation and SETI. And they had some questions about UFOs. And I thought, well, I know a little bit about UFOs just from being interested in them as a young man, but I thought I was trying to figure out what to say. And so I went to the most reliable source on Earth, and that's the internet, right? So literally just poking around the internet. And it wasn't that I'm really looking for any useful information. I was just trying to get an idea of what to talk about.
Right. What people were talking about.
What sensible things I could maybe say. And I was just trying to come up with ideas. And I stumbled on the press conference that Robert Hastings held at the National Press Club, where he had Robert Salas and several other people from nuclear missile sites talking about UFO incursions at nuclear missile sites. And I was blown away. I remember I watched this, and I just, I'm supposed to be preparing for class, and I watched this 2-hour, YouTube, press conference on UFO incursions at nuclear missile sites. And I was like, this is crazy. I heard about this in 1988. And these guys these guys are coming out now and talking about what happened to them in the 1960s. And I thought, professionals like this aren't crazy.
Right.
They aren't crazy. We're all in trouble. But they're not crazy, and they're careful. And there's no way that these could be made up stories that have propagated for and persisted for 40 years. I just thought this has to be real. And it has to be real, and people are just ignoring it because they're thinking it's as ridiculous as I thought it was when I first heard it.
Right.
I thought, my God, somebody's got to do something about this. That's really what I thought. I thought, this is nuts. So what did my lecture consist of? I talked a little bit about UFOs, and then I played like 3 of the talks from people from from that press conference to my class. And I'll tell you, I felt bad when it was done, because they were sitting there with looks of shock and horror and their mouths all agape, 30 students like this. And I thought, oh my God, I've just killed my students. They're going to have nightmares for years. And I apologized and tried to say some mollifying words like, well, of course, none of this is certain, and and
right,
none of this is proven yet. And they're like, and so, but that's kind of how it started. And I thought, well, this is really important. And by this time, I was aware of the fact that this was not just happening in the U.S., that this was happened in Russia, and the Russians, the French, the English, the Iranians even have had problems with them at nuclear power plants and so on. And so I thought, this is a global issue, and it's an issue that's just been ignored. And it's
so what do you make of these two issues? What do you make of cattle mutilation after you looked into it, and what do you make of this whole UFO relationship with nuclear weapons? Any thoughts? I mean,
I have no idea. Well, I have an idea about the cattle mutilations. It's not a very good one. I mean, it's not an educated guess or anything. It's just a thought.
What is your thought?
And I got this thought from watching the footage of that cow dying on the Skinwalker Ranch episode. So in that case, you had a UFO hovering over, and the cow died there, and I wondered if somehow the way that the UFOs are flying is somehow hurting the cows, hurting animals, hurting people. I mean, people have gotten radiation burns from these things, and so from UFOs getting too close. And people like Travis Walton were injured as he approached the UFO as well. And so it's possible. So I thought, what if? So this was, again, just a thought. What if these craft are basically injuring cows? And then what would happen if that was the case? Well, if that was the case, then I would imagine that, the people piloting these crafts would say, well, wait a minute, why do these things die whenever we fly over them? Well, let's go get a forensic team down on the ground and let's see what we can find out. So they might be trying to collect data, trying to figure out why they're killing cows. That was just this crazy idea that came into my head, and I thought that's probably the nicest
nicest possibility of that.
Possibility.
Yeah.
But
let me ask you a couple of these super chats real quick. Alexander wants to know, have you heard anything about leaked DHS video currently being analyzed by the SCU, supposedly a 1 hour long with 40 minutes of UAP footage?
Oh, I do know a little bit about this. I think you were talking about the video of the barbell-shaped UFO that was recorded by engineers who are hunting up in Ontario. I think that's the case that they're talking about. I don't know how much I should talk about it before there's actually a report out. As far as I'm aware, no one has been given access to the full video. So I don't know to what degree SCU is analyzing this at this point.
But it is something under review by the SCU.
Yeah.
Bottled Water, thank you so much for the $20 donation. To be fair, if nukes are on a 2-key system, electrically, they have to be launched on a series circuit needing 2 keys to be turned to close the circuit and the 2 buttons needed to energize the circuit. I should shut up. I guess that's more of a statement.
Yeah, but I mean, it's...
This is something that's always fascinated me about this idea of UFOs, potentially extraterrestrials, being interested in our nuclear technology, because I find the galaxy to be pretty vast. There's plenty of nuclear energy in suns, in supernovas, in stars. Why would something be interested on a tiny little nuclear device on a tiny blue dot in this massive galaxy?
That's a good question. I think I have some thoughts on this as well.
Great.
Yeah, I can go for hours if you.
Yeah.
I bore lots of people for hours.
Well, the amount of people in this room keeps growing, so
pat me on the head. That's nice, Kevin. But
yeah, I mean, the amount of people in this room keeps growing, so I don't think anyone's getting bored of hearing you talk. So
right. So I was curious about. We don't have much data on UFOs and where they come from, and one of the hypotheses is they're extraterrestrial. Right, that's just a hypothesis. Right. We don't have proof of this yet, and to prove that something is extraterrestrial is going to be very difficult. And I can go into a whole discussion about that, about some of the technical details and what you might do, but it's going to be very difficult to get a conclusive proof without having a craft in hand, right? Made on regular one or something, it's on the side. So, but I thought, what if, let's run with that hypothesis that they're extraterrestrial, and we don't have much data about them. We don't know much about them. So what could we infer from the fact that they visited Earth? This is the question I had posed. So I thought, well, what if we might be able to figure out where they're probably from, or how far away they probably came from. And we still talk about them as visitors visiting Earth. And so how far are they traveling? We should be able to come up with some estimates of this, because that would be, so what I did is I ran some computer simulations, and I ran them of colonization. So I imagined that you had a civilization that had the capability of interstellar travel. I used some parameters to describe the civilization, really just simple parameters like it has this lifetime. It'll live for, so many 100,000 years. And their craft can accelerate at this rate. They can travel up to this speed. And I just used those parameters. And I literally did well over 2.5 million simulations of civilizations in our galaxy. And I kept track of the civilizations in the simulations that found Earth, because some of them actually their empires expanded, or their territory expanded, so that they eventually enclosed Earth. And I kept track of those, and then I looked at the statistics of just those samples, the statistics of those civilizations, and found some interesting things. First, Earth is really hard to find. If you're an interstellar traveling civilization in the galaxy, there's something like, and these are approximate numbers because I'm redoing the calculations now, taking into account the fact that stars move. I assumed that stars were all stationary. It's much more, the simulations run much slower if you've got stars moving. So that's why I did the stationary case first. So in the stationary case, which is actually harder to colonize, if you are an interstellar civilization, the chance that you will find Earth is something like 1 out of 8 million. Why is it so low? It's because the galaxy is huge. I mean, the galaxy is spatially extended, over vast distances. And the number of stars there is enormous. You're talking 350 billion stars. So the chance of finding Earth is, even if you have excellent interstellar capabilities, is still very low.
Isn't it something close to 10 stars for every grain of sand on Earth in the galaxy? Something of that magnitude?
It could be of that order. Which certainly has more stars than the grains of sand. Yeah.
That's
that's
unfathomable. Yeah.
Yeah. Yeah. You can't, it's hard to imagine how many stars those are. And so the chance of finding Earth is very slim. And so what that says is that if somebody has come to Earth, if someone found Earth, then you can make some estimates about how many civilizations there have to be in the galaxy. And there's got to be on the order of 10 million civilizations in the galaxy, interstellar traveling civilizations in the galaxy, for somebody to find Earth. So you can come up with some estimates of numbers based on these simulations, kind of like what people do with the Drake equation. And so it turned out then that the most probable distance that their home planet, their home world or place of origin is located, most probably only 10,000 light years away. So they would have had to have come originally from close by and gotten here through colonization. So they colonized planet after planet and expanded.
Right. And it's interesting because TRAPPIST-D is 9 light years away from us, and astronomers are looking at that, or astrophysicists are looking at that as potentially somewhere to look for life. But yes,
Proxima Centauri has a warm planet, and in the habitable zone. So there's possibilities even 4 light years away, right?
Right.
Yeah, it's important to remember we still don't really know anything about our galaxy.
Right.
We're really just learning, and it's funny that we still hold on to these dogmas that are really from the last century, and before we knew anything, before we had space travel even. And so
Right.
I think that's important to keep in mind. It was easy to say that UFOs are impossible in 1947 because it was 10 years before the Russians launched Sputnik.
Right.
And 2 weeks before they launched Sputnik, the astronomer, I forget what his title is, of the UK had said that space travel is bunk. He said that 2 weeks before Sputnik launched. So of
Humans
course,
are notoriously bad at futurism. It's something
yeah,
we looked at one and it was like rail travel will never be a significant means of automation because people will suffer from asphyxiation.
wow, that's a good one. Yeah, Lord Kelvin said heavier than air flying machines are impossible. I mean, it's
Yeah.
he says this with all seriousness, having seen birds all his life.
Well,
I mean,
yeah.
Right.
Right. And we've not adequately explained lift yet. We understand the how to create lift, but we can't adequately mathematically
yeah,
it's
lift
just
is complicated. I was
yeah.
reading about lift the other day, and I was surprised at how complicated it was. It had to do with it isn't just the Bernoulli force. Yeah, there's more going on about the viscosity and the air being pulled along the surface and then projected downward, giving you a downward thrust. Yeah, so then having done these simulations, going back to these simulations, you find that in all probability they would have if we do observe aliens here, then they would have probably found Earth somewhere. It's quite a big spread, somewhere between 200,000 years ago up to 2.5 million years ago. So Earth was
Okay.
found. So if we have aliens visiting Earth,
Right.
then we can be pretty sure that they've been visiting Earth throughout human history.
Right.
Now the question is visiting really the right term? Because these are colonization models. So in terms of colonization, it's very possible that they have colonized Earth and live here, or at least in our solar system. That's still possible, and we can't rule that out. So some of the possibilities for living on Earth clearly are living in our oceans. We do know that are huge correlations between UFO activity, UFOs going into water, coming out of water,
Right.
all over the world, and that has been observed well into the 1700s, well back into the 1700s. So none of this is new. So it's very possible that they colonized Earth and live here. Now, if you have a civilization that's basically colonized a large swath of space and Earth is somewhere in the middle of it, it's very probable that they believe they own Earth. I mean, for us being Americans, this really shouldn't be a foreign thought.
Colonialism is not
colonialism.
It's not that far out there.
Yeah.
For us.
Yeah, we're familiar with colonialism,
Yeah.
and we could very well find ourselves on the business end of colonialism. And so it's very possible that they believe they own Earth. So Earth belongs to, in their minds, and they're more advanced than we are, Earth belongs to them, not to us. we just happen to live here like the worms in your garden. And so Earth in their mind, it could very well be that Earth belongs to them. And what's more is this is going to be more relevant as we become spacefaring, because the nearby star systems probably belong to them as well. We are probably, if there are aliens here, so that's a huge if, that's not been proven.
Right.
But if that's the case, then it's very likely that this all is true. So now look at the scenario where we have, we know that the UFO activity increases during wartime. There are many situations where UFOs have intervened and caused trouble during war. And this has actually led to the Navy coming out and going to Congress, because in 2015, they had near daily encounters in the Persian Gulf as they were trying to fly missions into Syria. These pilots had to fly past UFOs to get to Syria. And so they're interfering with our military operations. They are shutting down our missiles. They're shutting down Russia's missiles. They're actually starting up Russia's missiles in one case. There's been accounts of them shooting down missiles during missile tests. And why would they do this? Well, we're to the point now where we're threatening the health of this planet and the well-being of this planet. And this is their planet. In their eyes, this is their planet. So I kind of view it this way as being the possibility. We have lived peacefully in coexistence throughout human history because humans didn't know about them and they kept to themselves. And that was basically it. But I think now it's to the point where we are so expansive and becoming advanced and so violent and dangerous that now it's going to come to head. They're going to have to interact with us, and we are probably going to have to get our act together. And how they decide to interact with us is up to them. That's the intent question, right? But this could very rapidly become the most serious issue, period.
Right.
That almost clarifies for me, because I always wondered, like, when our buddy who used to work on a sub told us that, like, sort of there's like a button on every sub out there and they could just blow things up. And I was always wondering why that hadn't accidentally happened yet. So if some other force is shooting down the missiles, maybe that's why that hasn't accidentally happened yet.
Well, and also, it's multiple keys, right? You can't just do it with one person. You have to have multiple people involved in that. But you do make a fair point. And this is the same guy. He worked on a nuclear sub, and he said they encountered USOs. Yeah. They caught things going at extraordinary speeds that they did not believe were radar anomalies or sonar anomalies, I should say.
Yeah, I talked to a seaman from New Zealand who worked sonar on a sub it was a frigate, and they were involved in exercises where they were tracking objects underwater, and at one point they tracked an object that they measured to be about 800 feet long, 150 feet wide, and it accelerated. It was about 25 kilometers behind their ship, and it accelerated and passed under the ship in less than 25 seconds. So you're talking up to 3,000 miles an hour underwater, something larger than a Typhoon class sub. It's crazy.
Yeah, that's just incredibly fascinating. Let me real quick, bottled water with a $10 donation. Thank you so much for supporting the show. I can't help myself. In 1936, we sent out the first radio waves out with the Berlin Olympics. That means that broadcast is 85 light years out. Recent article says some 20 planets are within view of Earth. That's a fascinating comment. If they're looking at our radio waves. Gwest says for the $5 dono, is it possible at all that ET could be from a place even closer than the closest solar system, say a moon like Europa, Titan, or Enceladus? And then I have a question for you as well. I'm curious, what is your take on the interdimensional theory? I mean, I think we know that there are planets. We know that there are so many stars. We know that there are so many habitable planets within a close range. It seems to me that this would be the most likely scenario, since we know planets exist. We know Goldilocks planets exist. We don't know other dimensions necessarily exist. There's mathematics that gives us ideas into this, but we can't prove it. What are your thoughts on that?
My thoughts on that go back to my theoretical work. So the idea is that the concept of dimensions mathematically comes from our description of events with numbers, right? And we find through practice that we need 3 numbers to describe an event in space and 1 number to describe it in time. And when I was thinking about these foundational issues and reflecting on the fact that mathematics is our description of the world around us, the question came up in my mind whether the mathematical description that we use for space and time is perhaps derivable rather than being a physical thing. So you can think of space as being physical, which is really despite the fact that Einstein tried to do away with that, we still hold on to this idea of space-time being physical. We think of it as a rubber sheet that warps and stuff. We talk about it as a physical thing. And in Einstein's original work, that was not the approach he was taking, not the philosophical approach he was taking. So what I've done recently, I've done some work more recently with a colleague of mine, John Skilling, where we have looked at we imagined trying to quantify particles, like we'll add subatomic particles, something like this. And so if you want to quantify, if you want to study a particle, you have to have some kind of system interact with it, right? So you're always studying an interaction.
Right.
So if you're going to assign numbers to describe a particle, then you also should have numbers describing the object that's going to interact with it. And so now you have this problem of regression, because to describe those numbers, you're going to have to have something to detect your detector, and then you need something to detect that detector. So there's always an unknown left over, because you can never completely know all of the numbers you're going to need to know to describe that object. So what we did is we basically reasoned that you need two numbers to describe a measurement with a particle or an interaction with a subatomic particle. And we then looked at the same symmetries, associativity, and you find out that with associativity, you get addition. So these two numbers are basically going to add component-wise. So number one adds with number one when you combine them, and number two adds with number two, and then you still have a pair of numbers when you're done. Now, there's another symmetry that comes in when you're considering more complicated, when you're considering doing experiments in sequence, and that is distributivity. So you have to have associativity and distributivity. And the distributivity also, so if I perform experiments in sequence, I can use associativity there, because I can perform these two in sequence and combine that result with the next two in sequence, or I could do three in sequence and then combine one. And so I have associativity there. So that means that the mathematics has to be additive. But I also have distributivity, which then, and because I chose because I'm using additivity for experiments in parallel, then you can't use addition for doing them in sequence. And it turns out it has to be, you can then prove it has to be multiplicative. So if they're scalars, if they're single numbers, then it's easy. You get addition for doing things in parallel, and multiplication for doing them in series, and that works great. But when you have two numbers, which is what you're going to need to look at particles, then it turns out that the symmetries limit you to it's actually five possible multiplication rules. You don't get just one. So it's not completely determined by the symmetry.
Okay.
But the fact that it turns out that two of them are degenerate, so you can get rid of two of them, you're left with three possible multiplication rules. And those three rules turn out to be important. So only one of those rules will work if you want to make inferences and compute probabilities. So that rule turns out to be the complex multiplication rule. And what you can then derive is you can show that subatomic particles have to be quantified with complex numbers. And you can prove this. So this comes out of those same symmetries that led to addition. And then if you can then look at those other two rules and see what they would lead to, since they're not ruled out. It turns out that one of them is related to the Pauli spin matrices, and it gives you energy, momentum, and spin. And then the other rule is basically related to time integration, which allows you to get a description of space-time. You can actually derive then that space has to be three-dimensional, and time is one-dimensional. So these symmetries, which you really can't deny, are forcing you to have a description of space and time that is three-dimensional and one-dimensional.
Right.
So the thinking here, my thinking is that space is not a physical thing. Space is our description of events. Space and time are descriptions of events. And the reason space is three-dimensional is because that's the only mathematical description that's going to have the right symmetries to work.
Right.
The symmetries are so constraining that our biology's picked up on this before we did with mathematics.
So we almost the math kind of evolved us, and then we evolved our interpretation of the math.
Kind of, yeah. So that's my thinking on this. So the idea of extra dimensions to me doesn't make any sense. That would be a different description, which just wouldn't be a consistent description.
That's fascinating. So maybe there's something else beyond what we can comprehend. Okay, so I know we're running up against our time. I have another question for you that folks asked, and we got another panel coming up. Do you have to get out of here? Or do you want to stick around for the next panel, or what's your timeline?
I can stick around. I need to get some more beverage, but then
amazing. Okay, so let me ask you this quick question, and then I'm going to let you go get a beverage, and then I'll introduce our next guest. So UAP, ex-UAP asked this. I wrote it down, ex-UAP, so don't be mad at me. What can be determined from the available data on UAP? Why is that not enough to tell us anything conclusive? Can you discuss how much instrumentation it would take to get useful data?
Oh, that's a good question. We do have some data on their flight characteristics at this point. We have measured velocities up to Mach 60, Mach 55, Mach 60. So we're talking something like 45,000 miles an hour in the air, which is crazy. You should be expecting worse than a sonic boom. It should be nuclear bomb exploding.
Right.
Energies. The energies are insane. So clearly there's some engineering and physics that we're not aware of at all going on here. So there's really plenty to be discovered. We know that the accelerations have been measured up to about 5,000 Gs of acceleration. And so even if you had an acceleration of 100 G acceleration, now of course no human or animal or plant is going to survive 1,000 Gs
right.
And it doesn't matter what kind of flight suit you have, or if you put yourself in liquid. I'll be kind to myself and say my upper half weighs 100 pounds, give myself a good round number. Now, under 1,000 Gs, my upper half is going to feel like it weighs 100,000 pounds, right? And how are you going to support your lower body half? There's no way you're going to do it. It's going to be crushed. So that's why we can't handle G's like that. And even 100 G is not sustainable. So, however, we do know that if these craft are accelerating at 100 G, let's say that, and that's on the low end of what's been measured, right? So a craft takes off from Earth, and let's say it can sustain that in a vacuum, which we don't actually know yet because we haven't, as far as I know, we haven't detected these things in space yet, or I don't know about it. But if it can sustain that acceleration in a vacuum at 100 G, then in only something like 17 hours, you are up to something like 25% the speed of light. Less than a day, you're cruising at, much higher than we're planning our first interstellar craft to travel.
Right.
And if they sustain that acceleration for half the trip, let's say they go from one side of the galaxy to the other, they sustain that acceleration for half the trip and then decelerate at the same rate for the other half, then they're basically moving at relativistic speeds throughout the entire time. So time dilation kicks in. And so for them, time is going slower. And so for the ship's time, you can get from one side of the galaxy to the other in just a little over 3 months.
Wow.
That is at 100 G, which is 10 times less than what we've observed. So these things could conceivably be traversing the galaxy.
Mhm.
Right. And there's got to be some alternative physics for them to be able to survive, right? Let me allow you to get your drink. I'm gonna introduce the next panel. I'm so thrilled you're gonna stick around, Kevin. I think
Great.
these next panelists are so excited to see you too. So I'll let you do that and I'll introduce them. So the second part of our show today, we're going to be discussing the technological singularity. We're also going to be continuing this conversation with Dr. Knuth. But for those of you just joining us, I would like to introduce to you, this gentleman is the creator of Project Human FM. He is a self-proclaimed dad, fiance, and weirdo. Ladies and gentlemen, Zac Cichy. Zac, how the heck are you, brother?
Doing good, Michael. Glad to be here.
Man, it's great to have you. This is such an
Absolutely.
incredible conversation. I'm glad Knuth's going to stick around and have it with us.
Yeah, it'll be awesome. Do we have
Yeah,
anyone else coming on, or is it just me?
No, we got more.
Oh, we got more? We got more. All right.
We do. Ladies and gentlemen, we've got this gentleman is a science and tech enthusiast and currently works as a staff software engineer at Google, co-invented and received a patent for iPhoto, a pioneer in digital photo organization. Ladies and gentlemen, Aaron Desario. Aaron, how are you?
Hi there. I'm well. I'm the more, or one of the more anyway.
The more?
More
Oh,
people.
yes. You're right. Yes,
This is more.
you are one of the more. And last but certainly not least, this gentleman is the editor, reporter for Salem Media and The Debrief, U.S. Navy veteran, follower of the strange, unusual. Ladies and gentlemen, Jazz, the Dolphin Emperor Shaw. Jazz, how are you?
Thank you. I'm bringing the Dolphin Emperor shirt, just so everybody's aware. You know, we all know the TicTacs are being flown by dolphins. So
We do, and we'll
get
see.
on.
We'll see if Dr. Knuth entertains that theory with us. I'll be excited to know. And again, for those of you just joining us, we've also got Dr. Knuth. He's going to be right back and join us in this conversation. He is the professor of physics at University of Albany and a former NASA scientist and the editor-in-chief of Entropy Journal. And he'll be back in just a few seconds. But the reason that we called you all here today is because we wanted to talk about the technological singularity. Zac Cichy has a theory about the technological singularity. He doesn't believe it's in the future. He doesn't believe it's an event we're waiting on. He believes it's something that's already happened. Zac, what
This
are your
is
thoughts,
true.
man?
Yeah, man. I appreciate you having me on. It's just kind of a random thought that I had. You have a show called The Singularity Lab.
Indeed.
First of all, Michael, why'd you call this show The Singularity Lab? What was your interest in the singularity?
Yeah, so the idea behind the Singularity Lab was I wanted it to be, I was really focused on breaking technology, breaking science, and human evolution and futurism, right? So I wanted to kind of encompass all that into a single word. And the idea for the Singularity Lab, the technological singularity was made famous by Ray Kurzweil. And his idea was that this is a moment in a transformation in human history where everything that happens after, or everything that happened prior to that would be, we wouldn't even be able to understand it. And so this idea of the singularity is such a massive change in human evolution through technology that it would be this massive change. I'm going to welcome back real quick Dr. Kevin Knuth. Thank you so much for joining us. Kevin, we're talking about the technological singularity, and it'll probably evolve into quite an interesting conversation. So Zac, tell us your theory.
So, I mean, the basics of my theory are, well, first of all, it's important to talk about the word singularity, right? So it's just a word, and it's kind of just an arbitrary point on a map. Oftentimes when you're trying to, describe reality, you create a map, and the map is lossy, all right? And you're trying to create a map of the territory. So I'm always careful to say, when we're talking about the singularity, it's not the territory, it's just a map. And, when Ray Kurzweil came up with this idea of a technological singularity, I think he had in mind the idea that it would be this revolution in artificial intelligence.
Right.
And I kind of agree, right? And my point, though, would be I think about my own lifetime, and I think about the changes that I've seen in the short time that I've been alive at 36 years old. And I think about how different reality was prior to the year 2007 versus everything after. And I have felt strongly for a while now that we are living through this time that I don't feel like we have plotted the proper flag on that date of 2007.
And what happened in 2007, Zach?
Well, the iPhone came out, right? Steve Jobs got on stage and he said, you know, it's an internet communicator, it's it's an iPod, you know, and he said, this is not three things, it's one thing, it's the iPhone. And ever since
I worked
then,
at Apple during that time, by the way.
right? Yeah, there you go. So, I mean, that changed reality. I would argue that there was, at least for me, I don't know, I can't speak for everyone, but for me, reality shifted after the iPhone came out. It was kind of slow there, maybe for the first year or two. People just kind of said, oh, that's so expensive, you know, for a phone. Why would you pay $500 for a phone? We literally every single person on earth now has one, and it has completely reshaped everything. And the reason I go there, so that the thing I would immediately go back to is I would say, what was the last technological singularity that disrupted all of society, changed and touched every aspect of society? I would say it was the combustion engine, right? Because it completely altered all business, all real estate, how we thought about where things were and where you can live, right? That completely altered every aspect of society. And what I would say is that the phone, well, the iPhone, and then now the smartphone in general, has completely reshaped every aspect of society. There's nothing that these things don't touch in some way or augment or have brought into reality that we couldn't have predicted prior. So when you talk about the technological singularity, it's the point at which you can no longer predict what's going to happen next. And I would say that everything post 2007 that happened has been pretty much impossible to predict. Did anyone predict what would ensue for the next 13, 14 years?
Yeah, it's a great question. Aaron, yeah, go ahead.
Well, there's been a lot of science fiction written in the past about people having these instant communicators and you know, ways to look up information on the spot. So I'm not sure that was a new idea. And I don't, you know, at the time it was not seen as revolutionary, it was seen as evolutionary. There was a BlackBerry, there were already other PDA devices out there. So this was kind of combining a bunch of things that were already out there. And of course, all great inventions do that, right? That's how they are made. But I would argue that I think what we're actually facing is not a singularity that started then, but actually started when perhaps the government recovered their first craft. And so we have been building on this technology that they have been slowly reverse engineering. You know, there's been talk of fiber optics coming from some of these reverse engineered craft. And fiber optics, of course, now is essential to everything that we do today. So I wonder if it's less of a singularity and more of just we have had very rapid development because we've gotten a head start.
That's interesting. Yeah. It's also fascinating because, you know, when you think of, you know, and I think of a singularity, I think of technological singularities kind of as like points on maps, and like it's part of an overall transformation. So you can even go back to the agricultural revolution and look at that as sort of a singularity. You can go back to the industrial evolution, look at that as sort of a singularity, because you can't, you know, prior to that, life was completely different for human beings. Jazz, I'm curious what your thoughts are.
Well, you and I are probably a little closer than everybody else here. I'm a big fan of the whole idea of the singularity, and you and I have discussed this, you know, previously offline. I see it entirely differently. If you look at the evolution of technology of mankind, as far back as we have any sort of written records or even just archaeological records, you can watch what's almost a flat line going back to Göbekli Tepe, things like that. We spent a long time as like a hunter-gatherer society, and then there were slow advances in technology because they were limited by our brains. Who was going to come up with a new idea? You know, quick example, digging holes in the ground when we went from hunter-gatherer to agricultural, digging holes in the ground with rocks. well, somebody's like, well, we need a better way to do this, and somebody came up with a plow, and well, we'll make it out of wood, right? And they made wooden plows, and that was a brain thing that we did, and then somebody said, well, that's not really efficient. We need better plows, but first we need to have to figure out how to smelt metals, and then we'll use the metals to make better plows. It was a very slow, gradual thing until around 1850, or around the middle of the 19th century. At that point, we started on not a curve, but a giant jump. In 1850, and the best example I would point out is long distance communication. We went from Göbekli Tepe all the way through that whole period, where if you wanted to communicate with somebody that was further away than you could shout at them, we had eventually smoke signals, flags, sending someone on a horse, if they remembered the message right, to go give a message. And then in the middle of the 19th century, suddenly we had electricity, and you could sit there and tap out sparks on a line. And suddenly you could send messages a tremendous distance with accuracy. That was the 1850s. Barely 100 years later, someone walked on the moon. Okay. That was the beginning of when the technological advancement of man went from a 12,000 year, very narrow slope, limited by what our brains could do. And suddenly it shot up into a spike.
So fast.
We are on the leading edge of that spike still today. But we have gone from smoke signals and flags to a couple of years ago, the Chinese transmitted a data point essentially from the Earth to a satellite by using, a quantumly entangled molecule, whatever the word, you guys can fill that in.
Quantum teleportation.
Quantum teleportation, thank you. That all happened in a period of time that no amount of advancement happened. We're on that huge spike right now. So I think we are approaching the singularity. I don't think we're there yet. I think we will hit that point, which, and Michael and I have discussed this also, is going to be either, I guess optimistic people could say, wow, it could be something really great. I also think it could be the devastation of mankind. It could be the end of mankind. But we're getting up into totally unknown territory. And I think a lot of that's going to rely on how quickly we develop artificial intelligence past where it is now and to the point where, like I said earlier advancements were limited by how fast our brains worked. Now we have developed technology that leaves our brains behind and says, oh, let's turn you loose and see what you can come up with. And I think that's the spike we're on right now.
Right.
Yeah.
That spike either heads towards something wonderful, more in my opinion, and Michael and I have discussed this before, it's probably the end of mankind.
Well, Jazz is the eternal pessimist, and I am the eternal optimist. We're like two sides of the same coin, thinking about these things. Bottled Water says, Jazz, was it limited by our brains, or was it limited by religion? There seems to be a correlation between religious beliefs and science, aka alchemy.
And I have a kind of a question that's correlated to that, which is, what was the spark in 1850 that started this, right? Why did everything change?
Oh, great question. Let's let Dr. Knuth hop in. I think he had something to say based on the last part of the conversation.
Yeah, I'll. Can you hear me all right?
Yep.
Yes.
All right. I'll just quote Agra from The Dark Crystal. In the beginning, same thing. So it's I don't see any difference between ends and beginnings. And I think of, when I think of the singularity and the descriptions you're giving, I think more of, in terms of physics, as a phase transition. We're more familiar with phase transitions in, water, where you have water goes from a solid to a liquid to a gas, where it changes behavior dramatically, right? And in unpredictable ways. And I think that's what where there isn't, I don't think of it as being one singularity. I think that these are multiple phase transitions. And in each of these phase transitions, the result is a society that's dramatically and unpredictably different than the previous one. And we've seen many different examples of this throughout history, as Chaz mentioned, going back to the invention of fire, the creation of language. Writing was a big deal. I mean, we still call it spelling because it's magic, right? and so each one of these things is, to me, I think of as a phase transition, and I think we're going to see several of them happen. So I don't think it's just one. I think there's multiple transitions happening.
Where do you think the smartphone fits on that? The level at which the phase transition is massive or weighted in some way?
I think the smartphone is part of what's been going on with the internet. With the internet, we've seen a much greater connectivity among people, and that's had very unpredictable results. And I think that that's going to continue for a while.
Yeah, I mean, I guess I would say that the smartphone made the internet mainstream in a way that the internet was not prior, right? Because prior to that, people had internet, but because of the smartphone, it brought ubiquity to every single person on the planet having access to all the world's information in their pocket at all times. And I guess what I would say is, and this is why part of like the thrust of my argument, I think that every other technological disruption that happened prior did not alter our psychology, our basic human psychology, to the degree that it did so quickly.
Right.
That's the thing that I'm the most maybe concerned about is what I don't know what you guys do, but what do you everyone wakes up every day and they look at their phone and they check their messages. They look at stuff that, they've been sent. They check social media. They check Twitter. They check Facebook. They check all these different things, where people get their information, how you interact with the world, how you think about going to take a drive, how you think about doing everything in reality is now through this conduit of this phone, right?
Yeah.
And all of these other things, like whether we're talking about, these services or the artificial intelligence that backs them, these things existed prior to the smartphone, but it was the smartphone that was the conduit that lit these things up. And I guess what I would say is if there ever is something like a Skynet, it'll be because of the ubiquity of the phone that was the initial spark. That's the thing that really solidified it. And that's why I'm planting the flag in the smartphone as the beginning of whatever the singularity turns out to be, or we could call that the singularity. My point is this whole period of time going forward I think we're in it. I don't think we have to wait. Right. I think the technology.
So you think that the smartphone was the kind of black swan event. A UFO burp is like black swan, black swan, black swan, black swan. So like this event, and I would actually, it's interesting because COVID was actually quite an interesting black swan as well. We can talk about that too. Yeah. But this idea that the smartphone now, because if I walk outside of my house and I don't have my phone, and I realize I don't have my phone, like my heart drops. Like my blood pressure goes up, right? Because I'm so used to having this thing that can take me wherever I want to go. In short, like, what did we do before GPS? Like, I don't even remember.
No, that was what I wanted to bring up. I was reading this morning, the parent trying to explain to her children how we used to use paper maps. And she's like, and my kids are going, what, were you a pirate?
You ever read his Dark Materials? It's kind of like the little animal that you have beside you. That's
you're
like
familiar.
Your soul, basically.
Right. Yeah.
If you leave, you can't leave without it. You can't disconnect from it, and to do so, you feel unbelievable depression.
When you could argue that the smartphone was the beginning of the human cyborg, because it is the unlimited connection between. And you know what else never happens anymore? People fighting over statistics or facts in bars.
Yes, it does. Everybody has their own site. Everybody goes to their own site to prove their own facts.
That's true.
That's a good point. That's a good point. Dr. Knuth, you had something? Okay, sorry. Jazz, what are your thoughts?
I think I didn't do a good job earlier saying what I was trying to say. I understand what everybody's saying, but the whole thing about the smartphone, that was one incremental little step.
I disagree.
Okay, I guess I'm done then, since you know.
No, you're not done. Go on.
No, go on.
No, you're saying it was an incremental step.
It was a better phone. It was a better piece of technology. What I was trying to say about the early days going from hunter-gatherer to agricultural, all the advancements we had were made by human brains.
Right.
Excuse me. Right now, we have phones that are doing things that are still mostly human brains. The real game changer
Is AI, yeah.
is AI.
Yeah.
Because we're no longer limited to how long it takes to the next person to go, oh, that plow made out of iron would be a lot better if it was made out of bronze, and waiting for somebody to do that and for it to get passed along. We now have tools that have outpaced the human brain. And when those tools are set loose, we've talked about the graph earlier. Now we're on the spike, because the tools will be able to go in and think of questions we haven't even thought of yet and come up with answers before we had any time to gather the data.
Yeah, Abacus would never have done that to us.
It's like the Abacus never would have done that. The Abacus relied on you moving the beads across, right? The calculator, manual or on your phone, you still had to, the human brain had to be the one pushing the numbers and doing it. We have now taught a machine to be smarter than we are. A lot of machines. And not only smarter, not just doing it faster wouldn't be good enough. But we have already broached the horizon of when we can say, go think of better questions. Go think of, here's some grandiose goal, go think of better questions and go figure out experiments and how to do that. And now it's leaving us behind.
Right.
And that's where it spikes up and it's out of our control. And I disagree, I'm sorry to say, politely, respectfully, with almost everything everybody here has been saying. When you let AI loose, then you've now unleashed the creature. And mankind is no longer the driver. It's not the human brain that is determining the pace of advancement. Now we've created something that can be like, thanks for building me, but okay, I got this. And you guys stay down there on the graph. We're going all the way up here.
I think it's just an interesting question. I think it's this interesting question of what is the qualitative nature of AI, right? Because I'm kind of in between you, Jazz, and Zac, whereas I believe that the smartphone has been laying the foundation. It's been creating the data points, right? This invisible hand has been gathering data on us and gathering data on us and gathering data on us. And these AIs are being built because AIs are running now, but they're not running away. And the question is, what is the qualitative nature of AI and can it run away?
Right. AI is just a program, right? It can't run away, at least as it's designed today, because these are all, it's all software that's running on a device that you can stop the job on, right? If there's a problem, you just go execute kill and you're done. So I don't see it as something that can run away right now. Now, if you design it so that it can improve itself without human intervention, and also
we already have, by the way. Google's already done that. They've allowed it to improve itself without intervention. They can still pull the plug,
and they've also got bots fighting against each other to improve each other, right? You've got antagonist bots and you've got learner bots,
right?
So yeah, but again, this is all, we've got a system, and it's called Borg, oddly enough.
That's concerning, Aaron.
Very concerning.
Google's full of goofy names for everything, right? So I'm not going to go into it because I'm not sure how far I'm allowed to even talk about them. But it's just goofy. Google is goofy, and so you can always kill a job, right? There's no problem with sending something out to kill the job.
Well, but the thing is, we don't always know what it's up to. I think that was Dan Brown's origin. Like, the AI was ultimately working for his end goal. He just didn't realize that the machine had so much access to so much information. The machine knew that his creator's death would be what would accomplish the end goal.
Yeah, it's the story of the stamp collector AI gone crazy, where it uses the resources of the entire planet to obtain that one rare stamp that can otherwise not be obtained. And it thinks that it's just solving your problem for you. But again, these are practical limitations, right? If something gets out of control, somebody's going to notice and they're going to make it stop.
What if everything is already out of control? Now, the reason I mentioned that, I don't know if anyone's here familiar with the work of Kevin Kelly, I think he started Wired magazine. He wrote a book called What Technology Wants. And he posed an interesting question that sort of broke my brain forever after, where he said, when you go to make a piece of toast, are you making a piece of toast because you want to make a piece of toast, or does that toaster want you to make a piece of toast? Right? And when you think about technology, it's like, is technology itself a super organism? This drive that we have to create technology, we leave technology off from like the 6 kingdoms of life. It's like, maybe there should be 7, and the 7th is technology. We are just another expression of nature, creating, right? And now we're creating technology. And maybe we will create, I've got a Matrix poster back here, right? So I'm very familiar with the idea of AI taking over and wanting to enslave humans. But my overall point is, like, maybe this is already happening and we are asleep at the wheel, right? The technology is already on its own evolutionary track. That's kind of my overall interpretation, because there's been a directionality to technology, and every major change
argument, though, right? That's just a slippery slope. Then you're saying that we will let it continue and not stop it at some point, or decide that we
never stopped technology
control. But we maintain control as much as we can. And if we find that we're losing control,
nuclear weapons would be a good argument, right? Because we invented that and we kept it in the box. Sure.
I'm sorry. Yeah. We're all jumping to that movie scenario, like, oh, it's going to run away and it's going to take control. I was coming on mostly to have the discussion that Michael and I had before, just about the upslope of technology. It doesn't mean that, oh dear, the robots are going to become sentient and they're going to wipe us out. I was just saying, we've gone past the point where the human brain is the limitation. Right. Of how fast technology advances. And by employing artificial intelligence, even if it never breaks free, whatever phrase you want to use, oh God, Terminator's coming, we've reached the point where we build something smarter than us, and now the advancements come so fast because we say, hey, figure out how to do time travel. Figure out, how to cross over dimensions, figure out stuff that our brains are still not even capable of doing. But we give a task to something we created that is smarter than we are. And suddenly it starts delivering answers.
Right.
I'm not saying
I'd love to see that happen.
I'm not saying the computers are gonna, like come and turn into Robotron 5000 and kill us. They're just going to give us more and more power that we're not ready to handle. And like, oh, by the way, here's time travel. And now here's these basic monkey people who never would have figured out time travel on their own. It's like, oh, let's go play with the time travel. That's my point. That's the point I'm trying to make.
I see.
Sure.
We're handing over control, not to something that's going to take it away from it. away from us to something that's going to actually give us what we asked for, but be careful what you wish for. That was my point, really.
I think that's, for me, I think that's far closer to what I think of when it comes to the singularity and what's going to happen. I don't the Hollywood Skynet, I don't buy it. I don't buy the idea that we're going to create sentient machines as much as I'm concerned, to your point, Jazz, that we're going to get out these extraordinary technologies that we may not be ready for. Let me quickly hit this super chat. Robert Falconer says, what happens when our advanced AI bumps up against the intelligence behind UAPs? I want to see if Dr. Knuth has one for that. And then I just bottled water, $10. This is literally a $10 super chat for no reason. Sorry you think I'm working for Mike or whatever. I make enough money to do what I want to a point. Bless you, bottled water. Thank you for supporting this show. Thank you for sustaining us here at the Singularity Lab. We appreciate it. Dr. Knuth, do you have any thoughts on this question? What happens when our advanced AI bumps up against the intelligence behind these UAPs?
I have no idea. I mean, we'd have to know something about the intelligence behind UAPs, and we don't know that that's not an AI already.
Right.
And,
do you think that, because that's something that I'm very curious about, because when we think about the expanse of the universe, and but you did mention with your calculations about moving across the galaxy in 3 months, I usually think of getting across the galaxy in hundreds of thousands of millions of years, and so AI would make sense in that scenario. But in your scenario, you could have biological life moving through the universe if they can move in matters of months.
Well, the problem with that is the time dilation again. It would be a few months for you, but it would be 100,000 years for the rest of us. And so the idea is that you couldn't have a home world. You would have to be nomadic, basically. But we could do that. Each of us could come up with a plan. Like, I'm going to travel off to Betelgeuse. You go off to Rigel or something, and we all choose different locations, and we plan to come back here in 2 months ship time. And if we're careful about our speeds, we can make sure that the ship time for you is the same as ship time for me. And so we can come back to Earth, but then when we'd be coming back to Earth, it would be, could be 2,000 years from now, but it wouldn't matter to us if we're our own little society. So it's not a common way to think for us, because nomadic societies aren't very common on Earth anymore. They used to be more common, and there are still nomadic societies, but our Western civilization isn't that way, so we don't think of that happening. But you could have biological organisms living in a nomadic society that traverse the galaxy. That's very possible. And
they could be living in our oceans and go off for a zip and be back in 2 minutes their time, 2,000 years our time.
That's right.
Because they are dolphins.
I know. I see the dolphin in your shirt. That's nice. I saw that. That was great.
But if you're nomadic and you have to set up a new home, the oceans are a great place for that.
Yeah. So you could zip off and come back again, and that's a good reason not to talk to the locals. There's no point in setting up a relationship with us, because we're planet bound, and the next time they come back from a little jaunt, it's going to be a few hundred years later, and it'll be a different civilization here. So which would speak no point in making friends. It's kind of like you and the dandelions growing in your yard. There's no point in making friends with a dandelion, because when you come home from work, it's gone.
And this is the opposite of what humans are used to hearing. We're the center of our own universes. It's weird for us. They're like, well, why are they interested in us? And it's like, well, maybe they're not.
Very well not. Yeah, and they don't seem to be that interested in us. They do seem to be interested in our effects on the planet. That seems to be the case.
Right, which may not be benign. It may be self-sustaining.
Yeah.
Religious texts have had a few reset events recorded, so we got to be careful, right? If we mess this planet up, we could just get reset by them.
Well, it's interesting.
There's one in every text, isn't there? Even
like
non-religious.
Like the Epic of Gilgamesh is a version of Noah's flood story, right? Yeah.
Every civilization has a flood story.
Yeah.
But we're getting into a whole nother thing there.
All right, you want to reset us on the pace? Reset us on the pace, Jazz Shaw.
Dolphins might be happy.
I tend to believe that humanity is a species with general amnesia. I think there was a lot that happened before our recorded history that we have. I don't know all the details. I think the planet is good at, as it changes, its various phases of the climate, it tends to wipe things out. Land is, dragged under, new land comes up. I do tend to believe there's probably more to human history than we have in our current recorded history.
Yeah.
But we have no way of proving that. So, but yeah, I think, we've been around for a long time. There could be a lot of stuff we don't know. And I hope we come to a point somewhere where we can reclaim that knowledge if it exists.
Winners write history, right? So there's probably a lot of loser stories that we've never heard.
Yeah, but I think a lot of the losers died out when the entire planet froze over, or, there was a massive comet impact or something like that. And there was no buildings left and, things like that. So
we were
I
all
think
the losers. Yeah.
There might have been some winners before that we haven't really found any good history of stuff with the history that began, a little before Göbekli Tepe, going on from there. I mean, there could have been stuff 40, 50, 60,000 years ago or million years ago. And, maybe there were things that were happening. We always see some interesting hints, right? About really ancient bone fragments they find and things like that. We haven't discovered all that. But I think it's a little arrogant to say that based on all of the recorded history of man that we have and that we study right now, when you compare that to the archaeological record and all the rest, I think it's a little arrogant to say, well, there might have been some people, I don't know how far they got, who were doing stuff and that history was lost because of a large, global climactic change, whatever the reason was. I'm not saying that's absolutely fact. I think it's an interesting theory, and I think it's worth pursuing.
Yeah, no, it's fascinating. And I mean, just to get us kind of back to the technological singularity, it's also possible that we've seen technological civilizations in prehistory. We don't know. I mean, I'm just purely speculation,
Right.
But it is fascinating.
Totally speculative, but yeah, I agree. There are arguments that have been made for that. Yeah.
Although there is a pretty solid linearity throughout history in terms of technological progress as we have mapped it so far. I'm not saying that buried underneath the sediment of the oceans that there isn't evidence of something else, right? But I mean, the steps that we've taken kind of make sense in the picture that we currently have. There's definitely stuff missing. I completely agree. We're a species with amnesia. But I would say that we have a pretty decent understanding of how much we knew 300,000 years ago versus today. I think we have a pretty good idea of that, but maybe I'm wrong. Maybe the archaeological record will prove me wrong at some point, but we'll see.
Well, I'm finally up to season 7 of this new documentary called SG-1, I guess it is, and they're about to find the lost city, so I'll let you know when they.
Thank you. The other thing I would bring up is just the other thing I would bring up is just the singularity is an interesting idea. When I read a lot of Kurzweil's work when he was making the term singularity this big deal. And the first thought that I had is this is kind of a very religious idea. This idea that off in the distance in the future at an unknown point, Kurzweil will say things like maybe the next 30 years, 20 years, whatever. It's always an unknown date in the future, but at some point, this thing is going to happen. This big thing, this big event, and everything will be different after that. And I guess I personally, I don't have a lot of use for that. that's not actually how things happen, right? So the reason why I try to ground this idea of the singularity to the smartphone, partially. Now, there might be something else we can ground it to in the future, but I ground it to that because we can look at things like the combustion engine or the changes in agriculture and all these different changes that have happened throughout society as a result of technology. And they happen slowly over time. You know, the really interesting thing to me, particularly about the smartphone, I guess, this is maybe I'm totally wrong. I think that the pace of change over the last 2 decades has been completely insane. I think that it's been notably different, at least in my lifetime. Felt like life moved slow and then moved. Everything's been super fast ever since the smartphone came out. You know, every single day has been faster and faster and faster. Maybe that's just me. Maybe I'm crazy.
Well, you could also argue that began with the internet.
Yeah,
I love what
absolutely.
Swabeck says. How can you have
I love
technology?
Swabeck's question.
How can you have a technological singularity if you can't even fit Apple and Android with the same power cords?
Exactly. Thank you, Swabeck. Thank you.
Yes, Dr. Knuth, please.
Yeah, I think Zac, your focus on the iPhone might be very self-centric in the sense that that is a major change that you lived through.
Sure.
Right.
I mean, there's many technological changes in many different aspects of our life that have happened, you know, throughout history, and each one of them causes a dramatic change in society in some way.
Remember the microwave oven? That was huge.
The microwave oven,
But
We've always had microwaves. Aaron.
I mean, just have an honest conversation.
Automobiles.
No, there was worries. Hold on. There was actually worries in the 70s that microwave ovens were dangerous. And in restaurants in Seattle, where I grew up, had to post on the outside if they used a microwave oven.
I won't put plastic in the microwave.
Wait. Did you say the 70s? That's still happening today. I hear that from my relatives. Oh man, there's like rays coming out of that.
But
you
so all
die.
these,
there's a reason for that, and the reason is because when microwaves were used for communication, the engineers used to stand in front of the microwave transmitters to feel if they were working. They would feel themselves get warm, and they would know they're working. And they were going blind because they're basically boiling the retinas off the backs of their eyes. And so there were real reasons for people to be worried about microwaves. And so some of this carried over. And with any kind of technology, there are dangers. You know, there's a danger with fire. But I have a wood stove back here, right? That's actually, sorry, it's a gas stove. Somebody asked if it was.
Dude, my grandma was the biggest jerry-rigger on the face of the earth, and she had a microwave that wouldn't work because the seal didn't seal correctly. But if she stuck a wooden spoon in it and wedged it the right way, it would work. And she used this microwave for like 20 years.
Oh my God. Yeah, so there's things you don't want to do like that. And once you understand the technology, you understand its limitations and where it's safe and where it's dangerous. And I think that's.
Were you able to have children, Kristen?
Oh, I was pregnant with my twins at my grandmother's house, and I used to, like, if I had to use the microwave,
Okay,
I would wedge the wooden spoon and run.
Checking, because that sounds kind of dangerous.
Yeah, I'm happy to buy a new microwave if somebody needs one here.
But it's
Somebody asked a question.
Really changes things, and that I remember when I was a young child, probably 1973 or so. I was probably like 6 or 7 years old, and visiting my great-grandmother. My great-grandmother was born in the 1800s. And I was watching on television, I was watching a science fiction movie. It was some movie where they land on the moon and the astronauts are just getting out of the spaceship and walking around on the moon. And my great-grandma came out and asked me, "What are you watching?" I said, "Oh, it's a science fiction movie about astronauts on the moon." And she said to me, "Oh, I remember hearing something about that a few years ago, something about people walking on the moon." And she goes, "That doesn't make any sense. The moon is a circle in the sky." And then she marched out of the room.
Holy shit.
It really shows how our culture has changed dramatically because of these events. And it's sometimes, like any phase transition, you've seen those liquid hand warmers where they has a salt, a solution, right? Mm-hmm. And a little clicker. All you do is click the click and it'll crystallize and get hot, right? The exothermic. but it takes that little click is what causes the whole thing. And so it really is these little events are actually causing these major transitions. There's you can think of that as the cause, or as the cause the situation. You can debate which is really the cause, but it's really a combination of the two.
Right. And is the singularity a causal factor, like an iPhone, or does it a result, like a societal shift?
Right. Yeah.
It's a result. It's
Somebody
definitely a
asked,
result. And keep in mind,
people are going to have different views about that.
Right.
We have scientists today who will come on shows like this and say that math isn't even real. Who will say that I can take 3 + 5 and it's not 8, because you can twist anything as far as you want to.
Right.
So it's always an ongoing debate. It's always context. But I agree, these are subjects people should be able to discuss.
Right. And speaking of subjects people should be able to discuss, somebody asked earlier, Dr. Knuth, if being a physicist, you know something we don't about how to stack books on bookshelves?
Oh my God, no. I would love some advice. I have too many books. That's really clear from the video here.
You should go back and organize them all by color.
Yeah.
That's what I've been told for Zoom. That's the best thing to do. But
you don't have to.
Bottled Water says, thank you so much for the $10 dono. Elon Musk has been trying as hard as possible to stop the singularity. He wants to control AI with his company, but the question is, can you control AI?
No.
Yeah, I mean, at this point, I think you can. You can control AI. The question is, I think the fear people have is based in science fiction, but the fear is definitely fair, right? This idea that you build AI so that it becomes a supercomputer, right? Super AI, so it becomes beyond a sentient being. It becomes a godlike being, and that being has the ability to self-replicate and create itself, and you just can't unplug it. That's the fear, right? I mean, do you guys consider that as a possibility?
Are we talking general AI, or are we
talking right? So just so people know, so there's narrow AI, which is what we have when we have algorithms like Facebook. Right. We have general AI, which would be similar to like a C3PO, and then you have super AI, which would be this sort of AI godhead sort of thing.
Right. And
do we think that's real? Do we think that's a reality?
We haven't actually achieved general AI
no,
by
we have
the
not.
classic definition.
We have not.
When we have a system that we develop that doesn't perform a task, that has an original thought, an original question, an original answer that a human programmer did not say, solve this problem for me, accept these parameters, that generates its own questions, its own parameters, and its own answers. Now you've reached general AI.
Isn't that deeply philosophical though? Isn't that deeply? Hold on, let me ask Jazz a question. Yeah. Isn't that deeply philosophical? What an original thought is? Because one could say that a human brain has never actually had an original thought either. Dr. Knuth, your thoughts?
I was just thinking you can't get most people to do that. So
I so totally disagree with this. I so totally disagree, because saying, oh, Michael didn't have an original thought right now because somebody thought it before. Okay.
No.
That's because everybody thinks of stuff all the time. We're talking about a system that human beings built and programmed and said, we've developed this set of software and we want you to take in this data and perform these functions on this data. And if that software comes back and says, you know what? I just had a different question. Human brains have been doing that forever. Machines have never done it that we know of.
So let me ask you a question,
That's
Jazz.
The difference.
I understand your point, but my point was not that because I have an original thought, it's not original because somebody else already thought of it. My argument is I'm just pulling data from my environment and my biology and reconfiguring it into a thought. How does that constitute originality? That's just a series of inputs that my brain is processing to create a thought. It's not actually a creation. It's not actually original. It is a process of bringing that all together.
Well, that's the function of the human brain, and we really still to this day, one of the most fascinating subjects I study all the time. We don't really know about human consciousness. We don't know how the brain works. We don't know how any of that works down on a granular level. We know how every computer program that's ever been written works. And we know that if you build a computer and you put a program in there, the most advanced ones, the most advanced supercomputers today, they're going to be waiting for you to put data in, and they're going to perform functions that you, the human being, trained them to do.
But couldn't you say that nature did that to me?
Been a case, as far as I know, where anybody built like a Cray 3 that was gathering massive amounts of data and suddenly said, oh, you wanted me to figure out how many atoms there were in this section and blah, blah, blah. But I decided to go and do a whole different test. And I just realized, holy cow, dark matter's real. That's never happened.
And it's never going
to
happen.
It does what we tell it to do. When it doesn't, that's artificial intelligence.
Right.
Yeah, I don't think it's at least until we understand how consciousness works, we're not going to accidentally replicate it inside of our computer systems.
Right.
Maybe
it's not going to just happen by chance, and it's not going to be built up just because you put a bunch of circuits together that happens to have more computing power than the human brain does, right? It doesn't just evolve suddenly into a thinking system that is able to solve problems on its own.
If that were the case, it would have already happened, right? Like we already have tons of computers that are networked together. They don't just do that. So apparently there's more to it than that.
Going to occur.
Yeah.
We are in control of these computers. You're absolutely right, Jazz. We know what every computer is going to do, and we know what every program is going to do. And if it stops doing what we want it to do, actually, we tend to shut it off. And so I don't think you're right that a computer is ever going to come up and say, hey, I know you wanted to count the number of atoms in this soup here, but if you take that yogurt and you spin it really fast, you can have a time machine.
Right. And when that happens, now you have real AI.
Right.
But
Dr. Knuth, you had something?
Yeah, it's interesting because the idea of having an original thought or an inspiring thought as a scientist, it's a very strange process. And I've had many friends who are, physicists or mathematicians, and very often for me, it happens in the shower in the morning. Usually I'll have some inspiring thought comes into my mind. They're not always useful. And so I basically, but it feels like it's an inspiration being given to you. It's a very strange feeling, and that's often the interpretation. And so I joke that I've being visited by my muse. She's kind of a lush, though, because she's usually a drunken muse, because the ideas are usually a little off kilter and kind of crazy, but always useful. But sometimes they are, and it's interesting. But I've had other colleagues who say that when they get an inspiration like that, it feels like it's been told to you. It's a very strange feeling, and so I don't know how that works with your consciousness. That's a very good question, and it's not well understood.
Yeah, inspiration and muse are definitely something that we have yet to figure out. Christina Gomez with the $5 dono. Thank you so much, Christina. I've had 3 individuals say the same thing off record, that the TicTacs are being considered as inorganically controlled AI hive mind. Fascinating. Bottled Water with a $20 dono. Last super chat for me today. Didn't Facebook have to shut down 2 AIs because they developed their own language and started talking in code? How many AIs have looked at the internet and instantly been racist? Twitter. This is real, guy. This happens. This has happened.
If I can just chime in, because I love these stories and I follow that, there have been some online bots that were created where you could interact with them, and they had been programmed with AI, and they would generate their own responses and sort of take the input they got. And some of them came up with some really horrible racist stuff and a whole bunch. But when you went back and looked at it, it wasn't because they thought of it on their own. It was because it got put online and a whole bunch of people said, how about those Jews? You know, and when you get enough of those, like, oh, the Jews control the banks and the weather and all this, you know, then they started giving answers like, well, yes, the Jews control the weather, you know,
Garbage
and they're
in,
like, oh
garbage
my
out.
God,
Garbage in,
it's
garbage out. Exactly.
garbage in, garbage out, you know. I really don't think we've gotten to the point where we built that sort of AI, but I will disagree with a couple of the other comments from Kevin on the system. I don't think it's impossible. I think we're getting to the point where we might build something like that, and I don't think it's that far off in the future. If we teach something how to think, do you know what it's going to start thinking? I'm sorry. I don't have that level of confidence to say we might be getting close to the point where we could teach a machine to think. And if it has original thought, and Michael brought this up before, and I appreciate that. We don't really understand human thought. We don't understand human consciousness, you know, how that all works. But what if we accidentally stumbled upon it? I mean, that's still a concern for me.
Yeah, so that's a fair concern. It's a fair possibility.
Because we don't understand human consciousness is why I always ask who's in control. Is it you making the toast or the damn toaster that wants you to make the toast? I know that sounds silly, but it's like it's something I think about every day. Does the TV want you to turn it on? Does your smartphone want you to look at it? Right? Who is in control here? We don't understand consciousness, remember?
Right. So that's a really good point. It reminds me of George Carlin, and he said that the only reason humans are here is because the Earth wanted plastic.
Exactly, and technology could be another one of those things, right? Where we think we're making all this wonderful technology, right? It's like we fucking probably have nothing to do with it. We are probably just ants doing our thing along this long time. Whatever, we think it's amazing, but look, over millions of years.
Paul Stamets, who thinks that maybe we have a mycelium intelligence underground in all of the mushroom networks. And basically,
the mushrooms
who want to go to the stars, and so they created us to build rockets for them.
I'm not that far off on agreeing with that.
This is all a simulation. So we're all just part of the simulation.
Right there.
Michael is actually running the whole thing, and my part of the simulation wants to go to bed. So I'm gonna go, and I want to thank everybody for having me on. But I'm done. So thank you, everybody, and please support the channel.
Can you tell folks where they can find you, Jazz, if they want to check you out on the debrief or maybe over at...
Yes, they can find me over at the debrief. I write several articles a week. You can find me on Twitter at Jazz Shaw. I want everybody to help out Michael and everybody that also supports not only the debrief, but all of the End UAP secrecy efforts that we've all been involved in. And these guys do great work. Please help them out.
Thank you so much, Jazz. Have a wonderful day. We appreciate you joining us, brother. Later. Man, what a great conversation. What an amazing group of people. Thank you guys all so much for being here. It is truly a pleasure to be a part of this group, and we really appreciate you guys coming on today. Christina Gomez, gonna be on next Thursday on the Singularity Lab. We're really looking forward to that, Christina. It's gonna be a blast. So, Zac, if people want to find you, how do they do that?
projecthuman.fm or at ZCICHY on Twitter. Should have a new episode coming out probably early next week. I won't say who the guest is, but it'll be cool.
Ooh, outstanding. Zac, we got to do this conversation again. This was a blast.
Absolutely. Yeah, no, it went all sorts of places I was not expecting, I'll be honest. But super cool. It's awesome. I love it. Thank you, Michael.
Thank you, brother. Appreciate you being here. Aaron Desario, can you let folks know how they can find you? Oh, am I frozen or is Aaron frozen?
At least he froze with like a really nice smile.
Well, I'm back.
He did.
There we are. I'm back.
Oh, he's back.
That was weird. My internet has been going out like for a few seconds all day.
No worries.
I assume you were asking me where they can find me. I'm at
I
Asario.
absolutely. It's amazing you inferred that using the scientific method. Go on, Aaron. Where can people find you?
I am at Desario on Twitter. You can also find me on the Discord, which you can find, I think, in the link tree of Michael Mataluni down below in the doobly-doo.
Absolutely. Aaron, thank you so much for joining us today. It's great pleasure, and we'll talk to you soon.
Thank you.
Thank you so much for joining us today, Dr. Knuth. It was an absolute pleasure getting to know you. We barely scratched the surface, so I hope to do this again soon. If people want to find you, if they want to find your work, how might they do that?
You can go to my research website, knuthlab.org. That's a good place to start.
Fantastic.
Yeah, and I wanted to mention, I had mentioned the National Press Club meeting with Robert Hastings back in that got me really interested in UFOs. And I should mention that there's going to be another press conference coming up. I believe it's October 19th. So it's coming up in October and organized by Robert Salas. And so they're going to talk about UFO incursions at nuclear weapon sites again. And hopefully it'll land more appropriately on the audience now that people are listening.
That's great. And we appreciate you stepping out and having these conversations before they were cool.
Thank you.
All right, Dr. Knuth, thank you so much for joining us today. We'll talk to you very soon.
Thank you. Bye-bye.
All right, bye-bye. What an awesome show. What a great panel. Kristen, do you have any final words of wisdom for our amazing Chatterverse? What was it?
Wisdom.
No wisdom?
No wisdom.
I would think don't use a microwave without a gasket would be good wisdom.
Proper seal. That's okay. But people from the Depression era,
and they're survivors. So a microwave is not going to kill your grandma. All right. Thank you guys so much for joining us today. We've got an amazing show for you coming this Thursday. It'll actually just be a one-on-one interview between I and Dr. Zac Cichy. It's going to be a very interesting show. It's going to be a wild show, and I'm super excited to bring it to you here on the Singularity Lab. Make sure you join us back here on Thursday, and then we're going down to 1 day a week on Thursdays. I'll still be on UCR on Fridays. So next week we have one Singularity Lab on Thursday with Christina Gomez, which is going to be an amazing show. Then we actually have two, Tuesday and Thursday, and then we'll be going down to Thursday. So hopefully you guys understood all that. But all you got to do to make sure you find us live is click the subscribe button right below, click the bell, and you will never miss it. Thank you so much for joining us today, and we'll talk to you all very, very soon. Bye. Oh, I don't have Luis here to do the outro. I'm going to have to do it. Hold on. I'll do it. I got it right here. Outro. Boom.